Hi guys, it's WiredHack75 again here. Just wanted to show you some comparisons with some different LEDs and show you the LEDs that I'm using in all my projects. Right now you're seeing my really messy lab being lit up by one LED. I'm sure you've seen these around on YouTube. This is a 20 watt LED. Now it's technically an array. It's got a a matrix of individual dyes in there, but it's bright. Got all the lights off, and it really lights stuff up. It's 20 watts. I forget what the rating is lumen wise. I want to say it's 400 plus at 700 milliamps. But it's freaking bright. Cost me about 20 bucks from China. And unfortunately it needs 18 volts to turn on, so it really doesn't work for the applications that I want to use it in. You have to use a DC power supply. I'm using it on a 24 volt power supply right now with this driver, which is the one they sell for it, which is about 10 bucks. And the heatsink that it's on, which is the one that they recommend, and they're actually pre-drilled, is one you'd use for a solid state relay. You can see it's got a DIN rail mount there. But these are really bright and very efficient. They have a very wide viewing angle. Somewhere in this disaster. There it is. I don't know how well you're going to be able to see this, but there's the back of the heatsink. 87 degrees. There's 90 degrees. And this probably won't show up, but the front of this LED gets up to about 120 degrees. It's only been on for 3 or 4 minutes. But there you go, 134 degrees in the front of the die with it off. So gets pretty hot. Obviously, if you were to get a halogen bulb that put out that much light, probably be a hell of a lot hotter. But anyway, I want to talk about some of the LEDs that I use in my projects in these videos. Right now I've been using the Cree LEDs. These are the C503Cs, 15 degree angle. You can see the rating is 23.5 to 28.2. Only Candela. So I want to show you a cheap LED here. Chinese. That's blue. Of course, I'm not prepared. That's blue. Is this what I'm looking for? There we go. This one is just a cheap eBay 5mm LED. And I got 100 of them for like 10 bucks. If you look at the difference in output, the Cree on the left and that one on the right, it's obviously a better color. And you may not think it's brighter, but it really is. I'm running it on 3.3 volts here. I've got this breadboard power supply I got from Tautic.com. It was like $7, but it gives you 5 volts and 3.3 volts. So 3.3 is what this LED is designed to run at. So if I take this cheap one out, without any optics or anything, this Cree LED has a decent throw. And I looked on DigiKey. These go for 51 cents a piece. That seems excessive, but keep in mind this is a bulb that'll last for 4 times as long, if not more, than the cheap Chinese LEDs. Here's a cheap 4.8mm wide-angle LED. Some people call them straw hat. Some people call them low dome. I call this one garbage. Yeah, 10 of these for $1. Really, garbage. This is what you'll get in your Chinese flashlights. If we do the Cree, right next to it here, you can instantly see the difference. Cree actually puts out light. Again, on DigiKey, it prices out at 31 cents a piece. These are the C535A WJNs. And again, we're running them at 3.3 volts. So that's the real difference. I've been working with some blue LEDs lately too, and got a couple here. I don't have any blue Crees. Probably get some. Blue is my favorite color. I like blue as a kind of a night light. There we go. Also, in the fish tanks, the blue looks pretty good too. So here's now these are both eBay LEDs. Like I said, I don't have any of the Crees yet, but they look about the same on camera, I guess. This one on the left is the cheap eBay, just Chinese generic one. And the one on the right is from CLEDs.com. You see much better beam pattern. The other one's a little bit wider angle, but this one just puts out a lot more light. So yeah, it's still Chinese. It's not a Cree or anything like that, but you can see the difference. If you're going to buy LEDs for your project, don't just buy the cheapest ones you can find. You'll get burned in the end. But one of my next videos, I've got a video coming up here with some UV stuff, and also we're talking about battery life. I'm in the middle of a project now where I'm going to be running LED lights in all of my fish tanks, and eventually probably in everything. You saw my flashlight collection. The battery life with LEDs is amazing. This, for instance, is a Cree 503C LED running at 3 volts. It's running off 2 AA's here. I've got this little bi-pin connector, 2-pin connector. Great, quick, cheap. These things are like $1. I paid 75 cents for this. Cheap way to, just test LEDs real quick to either A, see if they're working, see what color they are, if you got a bunch of them laying around like I do. These things are designed to run at 25 milliamps. I've had this one running for over 2 weeks. It's not as bright as it was when it started, but it's still on. In an emergency situation, this is enough light to not be in the dark. But obviously you can see the advantage. I mean, 2 weeks, you're really going to need to leave something on for that long. I mean, at any rate, we're going to be doing some testing with battery life. And also I'm going to be working with these lithium-ion cells here. I found a charger for them. These are out of a Dell laptop battery. You can see the ridges where the strap was punched on. These are 3.7 volts. And it's a great voltage for LEDs. You just use a dropping resistor or regulator or whatever and run it. Like over here, I've got this is one of the desk lamps that I hacked with the Cree LEDs. You can see it's putting out a nice amount of light. We've got it running off this lithium-ion battery pack here. That's a 14.4 volt battery pack. This light runs on 12 volts. And so far it's been on for 6 hours. That's enough light to read a book by. Light up a room in a power outage, hurricane, whatever. So we're even doing videos on really on efficiency and just the absolute usability of LEDs. If you're not convinced yet, just give me a little while, I'll convince you. LEDs are the way to go. There's no toxic chemicals, there's no gases, nothing to break really. And eventually they're going to be so cheap that everything will be lit by LED. The government's phasing out incandescent lighting, so. But that's it. Stay tuned, we got more to come.